All right, today we're going to build something. We're going to lay the foundation for pretty much any modern machine learning system out there. We're talking about the core tools that take your brilliant code from your laptop and actually get it into the hands of millions. So let's just dive right in. This right here is the absolute heart of the matter. And I want you to notice that key phrase, a set of practices. See, MLOps isn't some magic tool you just install and call it a day. Nope. It's a philosophy, it's a culture, it's a whole workflow that bridges that huge gap between data science and solid software engineering. It's all about making machine learning work and work well in the real world. And this is the million-dollar question, isn't it? That amazing model you spent weeks training, the one that gets incredible results on your machine, that's just the starting line. The real race is production. How do you serve it? How do you scale it? How do you maintain it without everything just catching fire? Well, that massive gap is exactly what we're going to close today. To really get our heads around this whole production nightmare, I want you to stop thinking about your ML system as just a piece of code. Instead, let's imagine we're building an entire city. Trust me, this analogy is going to guide us through the whole thing. Think about it, right? A giant skyscraper is an incredible feat of engineering, but it's completely useless if there aren't any roads to get to it, a power grid to turn the lights on, or water system. Your amazing model? That's the skyscraper. And MLOps provides the roads, the power, the plumbing, the entire city plan.
So, where does every city start? With a master plan, a detailed blueprint. And in our ML city, that master blueprint is created with a tool called Terraform. It lets us define all the foundational infrastructure before we even think about laying the first brick.
Terraform is all about this incredible concept called infrastructure as code. So instead of a human manually clicking around in a cloud dashboard to set things up, you write code. You literally write a file that says, hey, I need a Kubernetes cluster with 3 nodes of this size, or I need a database with these exact specs. This makes your entire setup perfectly repeatable, you can track changes in Git, and it's completely automated. Now, the workflow here looks pretty simple, but step 2 is where the real magic happens. Manage state. Terraform keeps this special file that's a perfect record of everything it's built in the real world. That state file is the single source of truth. It prevents conflicts and lets Terraform know exactly what needs to be added, removed, or changed. Then it just makes it so. Okay, so our city blueprint is drawn up, the land is ready. Now we actually need the buildings themselves. The offices, the apartments, the factories. In the MLOps world, those buildings are all packaged up with Docker. So Docker uses this technique called containerization. Just imagine putting your ML model, all its code, and every single specific library it depends on into one standardized, perfectly sealed box. The beauty of this is that the box, the container, will run exactly the same way absolutely anywhere. Your laptop, a test server, the cloud, it doesn't matter. It completely destroys the, well, it worked on my machine problem forever. And this is a really clever pro-level technique you can use with Docker. It's called a multi-stage build. When you construct a building, you use all this heavy machinery, right? Cranes, cement mixers, but you don't leave the crane inside the finished apartment, do you? Of course not. A multi-stage build does the same thing. It uses all the heavy tools to build your application, then it packs only the bare essentials into the final container. The result is a much smaller, faster, and way more secure package. So the promise of Docker is really simple, but incredibly powerful. It gives us reproducibility and portability. Your code just works everywhere. It isolates your applications so they don't mess with each other. And you can build automated security scanning right into your process, so you can find and fix vulnerabilities before your container ever sees the light of day. All right, so we've got our city plan from Terraform, and we've got our prefabricated buildings from Docker. Now we need a city manager. We need a powerful operating system to place all these buildings, to manage all the traffic, and to allocate all the resources. And that, my friends, is Kubernetes. Now, the most basic unit in the Kubernetes world is called a pod. You can think of it like a little plot of land that holds one or more of our Docker containers that need to work really closely together. They'll share things like networking and storage. It's perfect for running your main model container right next to a little helper container that handles logging or metrics. Next up, you have a deployment. And this is where you tell Kubernetes what you want the world to look like. You declare your desired state, saying something like, hey, I need 5 identical copies of my model's API pod running at all times. Kubernetes then works 24/7 to make sure reality matches your request. If a pod crashes, it spins up a new one instantly. And when you update your code, it does a careful rolling update to ensure zero downtime. And finally, the service. Okay, so pods can come and go, right? They get replaced, they get updated, which means their internal addresses are always changing. A service acts like a permanent street address for your application. It gives you one single stable endpoint to send traffic to, and it's smart enough to route that traffic to whichever healthy pod is ready to handle the request. And this is where Kubernetes just blows everything else out of the water. We're not talking about managing a few containers. It is designed from the ground up to manage thousands, even tens of thousands of them, running across a huge fleet of servers. But how on earth does it handle that kind of scale and complexity? Well, the secret weapon is auto-scaling. Kubernetes is always watching. It's watching the traffic, it's watching the resource usage in real time. So when a huge wave of users suddenly hits your model, it automatically scales up, adding more and more pods to handle the load. Then, when things quiet down, it scales back down to save you money. It's a living, breathing, dynamic city. So let's step back and put this all together. By combining these three incredibly powerful technologies, we've done it. We've built a complete, an automated, and a truly scalable foundation for our entire ML city. And here's the whole workflow in one picture. Terraform is the architect, using code to lay out all the cloud infrastructure, the Kubernetes cluster, the networking, the storage. Then Docker comes in as the manufacturer, packaging our ML application into those perfect portable containers. And finally, Kubernetes acts as the city operator, deploying, managing, and scaling those containers to meet any demand you can throw at it. And that really brings us to a final, pretty exciting thought. By automating this entire infrastructure and deployment layer, we've solved one of the biggest, most painful headaches in machine learning. And that frees up the world of MLOps to focus on the next frontier, building sophisticated CI/CD pipelines just for ML, automatically detecting data drift, creating fully automated retraining loops. The foundation is now set. And now the really interesting work can begin.